Good morning, New York, and welcome to everyone that's joining us from around the world. My name is Nicholas Vanousis. I'm the Executive Director of the Horological Society of New York, and it's my pleasure to welcome you here to our March 2022 meeting. As usual, let's get started with a few announcements. So it's your last chance to see our Horology in Art exhibition. It's on display through April. So you've got just under 2 months left to come and see it. It's in our office in Midtown Manhattan. It's a fascinating exhibition, and I really recommend if you're in the city and you have a chance to stop by, please do so. And we're looking forward to many future exhibitions coming through the space as well. So we'll be announcing those shortly. And education updates, of course, we have our New York evening classes every week, and we have a New York weekend class coming up on March 19th. Those weekend classes are very popular. They're selling out quickly, so be sure to get your tickets if you want to attend a weekend class. And of course, we still have our virtual classes that are available. If you're not local to New York, we'd be happy to come to you via video conferencing. And I'm very happy to announce our 2022 gala. After a 2-year break due to the pandemic, we're back and we're bigger than ever. This year, we're going to have the gala at the Harvard Club of New York City, which is directly across the street from the Horological Society on 44th Street in Midtown. And what I was thinking I would be doing today is I would be advertising the gala, asking everyone to buy a ticket, encourage people to come and attend the gala. But the gala is now completely sold out. So I want to thank all of our members and sponsors for the overwhelming response to the gala. I think people are very excited for it, as am I. So I'm looking forward to seeing everyone there. And I'm looking forward to restarting our gala tradition every year. I'm looking forward to 2023 and onwards into the future. So we'll see everyone April 9th at the Harvard Club of New York City for our 2022 gala. Okay, on to today's program. When I think of ultra-thin watches, I think of a watch that is probably very expensive. It's probably like a limited edition, very small production quantities, and maybe a watch that is somewhat fragile. You need to treat it with extra care. So Nomos has turned all of that around with their next generation movements. These movements are very sturdy, they're very thin, they're moderately priced, and they're produced in much bigger quantities than you may imagine. So what we're going to do today is we're going to take a close look at how that was possible. We're going to look at the technical side of things and figure out with the help of 2 experts on the subject of how that was really possible. So today's lecture is titled Next Generation Nomos Movements, Thin, Automatic, and Highly Precise. And we're going to be joined by Mr. Theodor Prenzel, Head of Design Engineering at Nomos Glashütte, and Ms. Martina Etti, Head of International Sales at Nomos Glashütte and co-CEO at Nomos Glashütte in New York. So Martina, Theo, please take it away.
All right, thank you so much, Nicholas. And yeah, thank you very much for having us and for this great opportunity to give an insight here into what Nomos does in Glashütte. Before I leave you in the talented hands of our Head of Design Engineering, Theo, a brief outline of the development of the manufacture over the years. I'll share my screen. Why do I show these people here? Nomos is an independent and owner-managed manufacturer. Founder Roland Schwertner, CEO Uwe Arendt, and head of brand Judith Borowski, as you can see them here, are active managing partners. With more than with more than 200 employees and 3 premises in Glashütte and 5 subsidiaries internationally, Nomos is the largest manufacturer of mechanical wristwatches in Germany in terms of produced volume. Right now, we produce 11 in-house calibers in all in the small town of Glashütte. This is the first one of our premises, our headquarters, the remodeled train station, where all our watchmakers are situated up the hill in the building called Chronometry, and our machine hall in another part of Glashütte, where all the parts, wheels and pins needed for a movement are produced. Our communication and design department in Berlin, Kreuzberg, and just to illustrate how small this little city is and how close to each other Glashütte's manufacturers are situated, our conference room on the station building, the glass cube you see on the right side, is opposite of the Langes historical building, the one with the clock on the top, and Glashütte Originals headquarters to the left. You can see we literally look into each other's windows. What you can't see behind us is Moritz Grossmann, or further up the hill, Wempis Chronometry. So that is Glashütte. Yeah, it's considering that contemporary luxury watchmaking in Glashütte could only start after the fall of the Berlin Wall in 1990, the row of 11 in-house calibers, as you see them here, makes us a bit proud. It all began with the lineup of 4 models, simplistic and elegant, with a classic hand-wound movement. By the way, the very first watches that came into the market from Glashütte after the German reunification. Many years, everything the watches earned was invested in the step-by-step development of a full in-house movement. This is why in 2001, the first Nomos watches with date could be equipped with an in-house developed patented date mechanism, constructed in a way that kept the watch as slim as without date. The same applies for the patented construction of Nomos' very special power reserve indicator, introduced in 2003, constructed directly on the core barrel. The increased know-how over the years enabled the young manufacturer to present its first automatic movement in 2005. And a GMT caliber based on this in 2010. This complication rounded out our collection on the side of larger watches around 40 millimeters, like Zurich on the right side. 4 years later, another milestone for Nomos independence made big waves in the industry. 7 years of research with the Dresden Technical University and 11 million euros investment resulted in an in-house escapement, the most delicate yet crucial part of a movement. You see it from the headlines, big waves these days, 2014. But we didn't stop there. The next big goal to develop Nomos collection further was a slim automatic movement to equip our elegant hand-wound models with a self-winding motor. These slim automatic movements came with their own category, Neomatic, and my colleague Theodor will now report much more competently on these last 2 developments. Theo?
Thank you, Martina. Thank you, Nick. Today, I would like to show you the latest developments of Nomos Glashütte. And let's start with the screen sharing. Okay. I'm going to talk about our latest pneumatic movements, DUW 3001 and DUW 6101. 2 movements of the next generation. How was it possible that they could be so thin? We will talk about the 2 major designs. And by the way, if you have any questions, as this is a video call and it's not very easy to manage those things, please hold your questions until the end. There will be enough time to deal with them. Okay. Namely, DUW 3001, an automatic movement with automatic winding and the possibility of hand winding, of course. Just have a look at this. I think a quite beautiful movement and a typical Glashütte movement, also a typical Nomos movement. But what makes a typical Glashütte or Nomos movement? Basically, the design. Instead of two bridges, the barrel and the gear train bridge, we have what we called the 3/4 plate. 3/4, obviously, because it's not a full plate. It covers 3/4 of the movement, and it makes the movement very, very stable. Also, we are able to produce the movement in high amounts. So it's very cost efficient, and we don't have to leave the normal price range. So what is so special about it? I can tell you, it's the height, or should I say the thinness. Maybe it's not the thinnest movement in the world, but it's one of them. It has a height of only 3.2 millimeters. So let's give you a few key facts. Let's start with the name, DUW 3001. DUW standing for German Watch Manufacturer. In German, Deutsche Uhrenwerke. This is the label under which Nomos produces and of course sells and uses the movements. We have a diameter of 28.8 millimeters, and these are 12 3/4 Horatian lines. We have 24/7 jewels, and all in all 157 parts. What else is special about the movement? You already heard it from Martina, the escapement system. So the lever, the escape wheel, the balance wheel. These parts are the heart of every mechanical movement. Without this system, no mechanical movement will work. And just a few brands in the world are able to produce those complicated systems by their own. And Nomos is one of them. And this escapement is called the Nomos swing system. Of course, the movement is nicely decorated and the movement hacks. You know what I mean? In the technical speech, it had a stop-second mechanism. I have talked about the low height, and I think this slide is perfectly able to illustrate and give you an idea how thin the movement is. On the top, you can see it here, there's our signature model Tangente 35. The 35 stands for a diameter of 35 millimeters without the crown. With our famous hand winding movement Alpha. So it's not an automatic movement, and the watch case has a height of 6.6 millimeters. If we go directly to the bottom, so just skip the middle for a minute, we have here model Tangomat, an automatic version of Tangente, a bit wider in diameter and a bit wider in the height, and it's powered by the DUW 5001. Classically a traditionally designed movement. Okay, and now please go to the middle. This is the new Tangente Pneumatic 3001, and you can see how thin it is. It's an automatic watch. It's a bidirectional winding watch with a height of 6.7 millimeters. So there's just the difference between the hand winding case to the automatic case of only 0.1 millimeter. That's really nothing. So the question is, how was this possible? The first design principle is the layout of the movement. At the left-hand side here, we have the 3001 movement, the new, the fin movement, the latest development. And on the right side, there is DOW 5001, as like before shown in Model Tangomat. It's a classical movement. At the first view, they look the same, but the differences are in the detail. So what we will do next, we will assemble both movements to see the different design layouts. Let's start with the classical build movement DOW 5001. Here we have the base plate, the main plate, and the stem here is already mounted, and there's no drivetrain, no nothing, just a few jewels. In the next step, we are mounting the gear train here with the barrel, the gear train, the escape wheel, and the second step lever, and after that our famous Glashütte 3/4 plate. And then we have the hand winding mechanism, which also needs to be included. Okay, so remember, we have the main plate, we have the gear train with the 3/4 plate, and we have the hand winding mechanism. And after that, we can now have basically the automatic winding mechanism to wind up the watch in an automatic way. And last but not least, we have the rotor, the weight which produces the energy for the mainspring inside of the barrel. Okay. Here we can see all the parts in one slide. And this all has to be stacked on top of each other. And of course, this consumes a lot of height. It's a classical sandwich movement. Maybe you might asking, why is Theo so crazy about the height, or Nomos, or the whole watch industry? Well, traditionally, craftsmanship of watchmaker is shown in minimization, making things smaller. For us, a thin watch is an elegant watch. And now let's have a look to the new movement DOW 3001. Again, in the first step, we have our main plate with the winding stem. And then basically we came up with the idea, why not integrating more parts than before between the two plates, between the main plate and the 3/4 plate. And we decided to put the drivetrain and also the automatic train between those two plates. And now only the rotor and some parts of the winding mechanism came on the top. And then we are finished. This is now the result. We have half the number of sections, not the number of components, not the number of parts, no. We integrated two levels. You can see it here. In the top, we have 4 sections, 1, 2, 3, 4. And here in the bottom, we have only 2 sections, the main plate and the 3/4 plate. Also, we are nearly half the part tolerances and tested lots of different materials. The ratchet wheel here, for example, which is in the new layout under the 3/4 plate, have to be very, very flat. And through the normal hardness process, such a thin part normally gets bended due to stress inside of the material. So we did lots of research, and now we use a special steel alloy with which the bending are in our small tolerances. So we have the number of sections that had to be stacked on top of each other, and the result is a super slim movement and demonstrates the craftsmanship and allowing for very, very thin watch cases. Both movements, the 3001 and the 5001, are bidirectional winding. So there's no matter in which direction the rotor revolves, clockwise or counterclockwise, it doesn't matter. It produces energy in both directions. However, the mainspring inside of the barrel can wind up only in one direction. So a system is needed which converts this bidirectional winding into a monodirectional. In the 5001 movement, we used a so-called sliding gear assembly. Here on the top, you can see there are two wheels mounted. And depending on the direction of the rotor rotation, one or two wheels are measured, and all here of the wheels of the automatic train revolves in just one direction, also the winding of the mainspring. In the 3001 movement, we had a complete other system. We used the so-called twin pole winding wheel. We have two sections here, two gears, and in both sections there's a blocking mechanism. So this system is not an invention of Nomos. Other brands use the system too, but for Nomos it's new that we produce and assemble nearly all parts of this twin pole winding wheel by ourselves. The whole assembly consists of 12 single parts, and it's very difficult to mount because of the small part sizes. And the height of this complete system is about just 2 millimeters. Let's have a short summary. We talked a lot about the minimization of the height to make a watch thin. I hope I have been able to show how we put the most parts between our main and 3/4 plate. Another big achievement is not about the size of the watch, but it's about the performance of the movement, the automatic winding mechanism. This system converts the motion of the arm, the motion of the watch to energy, and which is stored directly inside of the barrel mainspring. So there are two things we keep in mind. The first one is, how big is the power reserve? How many hours the watch can run if it's not worn? And second, how often do we have to move our hand and how fast or how quickly can the maximum power reserve achieved? Maybe you know this situation. People sit concentrated on their desk all the day long without lots of motion. Often they are wondering why the watch has stopped on their way home. Simple reason, there was not enough motion. The power reserve gets empty and the watch stops. And now let's walk through the chart here. We have here different movements. We have the red color and this light purple is the Nomos 3001 and the Nomos 5001 movement. This yellow color is the Rolex 4145, and this purple and blue color are the ETA workhorses 2822 and ETA 2892-2. So they are all very standard movements. And what we've done, we put all these movements to winding machines. Winding machines, they move the movements anytime. And in the beginning of the tests, the power reserve was empty, of course, the watches doesn't work. And how longer the movements are on the winding machines, the power reserve gets higher and higher. So you can see it here, the bars in every testing stage are longer and longer. And what you can see is that in nearly all of the testing stages, the red bar is the longest, or the height. So that means the 3001 movement is, from the tested movements, the most efficient movement with the automatic train. For example, you can see it here, after a testing time of 120 minutes or 2 hours, the ETA 2892 produces nearly 30 hours. The 3001 movement produces after 2 hours nearly 44 hours. That means nearly 30% or 1/3 more power generated the 3001 in the same time. So the automatic train is very, very efficient. Here also we have some further explanation. I hope I not bore you to death. What we said, how much power reserve can a movement have? That's easy. Some have 48 hours or 42 or 43, and some only have 30 hours. The other thing is how fast this is generated, how long I have to wear the watch to achieve the full amount of power reserve. This is defined basically by 2 things. First of all, how often has the rotor have to revolve? How many revolutions do we need to build up the power reserve? This is given here in the second line. Number of rotor rotations required for 24 hours of power reserve. 24 hours because it's a value which is achieved by all of those movements. 24 hours, that's quite a reference. If you look to the first 3 movements, we have nearly 500 rotations of the rotor to produce 24 hours of power reserve. And now let's have a look to the Swiss workhorses here. Nearly 600 rotor revolutions are needed to build up the same amount. So in other words, 20% or nearly 100 revolutions more than the other 3 movements are needed. The second point is, we call it the winding angle. Here in the first line. This angle or this word is a little bit misleading because you can also call it the dead angle. And it's a useless angle. If the rotor change its direction from this to this direction, for example, there's a clearance. There's an angle during the rotor doesn't produce any energy. In 3001, we have a winding angle of 10 degrees. That means if the rotor changes direction from this to this, for example, we have 10 degrees where the rotor doesn't produce any energy through the clearance of the gears. If we look to the 5001 and the Rolex movement, we have nearly 40 degrees. That's a lot. It's really a lot. But all in all, this is not a problem because both movements use very, very heavy rotors. And so also with small motions of the arm, the movements wind up very, very good. In comparison to the 10 degrees of 3001, if we look to the Eta movements, they are much higher. And this is the reason why the Eta movements wind up not so efficient, wind up not so fast or quick. Okay, I hope this is clear. The next step is the second biggest innovation. Our latest movement, DUW6101, a movement with a date indication. If we remove the rotor and the 3/4 plate, we can look into the movement. And here in this CAD picture, you can see it too. Nearly all parts are mounted again between the main plate and the 3/4 plate. So it's a movement of the newest generation too. I already said it's a date movement. And of course, I think the most impressive part is the date disk. So it carries the number from 1 to 31. Of course, for every day of a month has its own number. And in the movement, we have here a section for the quick set function. And on the left side here, there's the section for the date change during the midnight. But before I give you some key facts of the movement. We have a diameter of 32 millimeters of the main plate. But what you can see, the date disk here from the other side is much more wider than the main plate. So if we include the date ring, we have a diameter of 35.2 millimeters, and these are 15.5 Parisian lines. The height with 3.6 millimeters is again this very, very thin movement. We have again 24/7 joules and all in all 188 parts. The power reserve is about 42 hours, 1 hour smaller, shorter than the 3001 because the date function needs some more energy. So the power reserve is 42 hours. The date function, or the correction of the date function, this is very unique for this movement, is both directional. That means if I pull out the crown to the first position, to the quickset position, I can change the date into 2 directions. I can change the date clockwise or counterclockwise, depends on the rotation of the crown. And so it's very easy and very quick to change the date to the date you want to set. And how is this working? If you pull out the crown, the wheel here with this 5-arm star is measured with the crown. And depending on the direction of the rotation of the crown, also this wheel rotates clockwise or counterclockwise. And of course, the date disk rotates in both directions. Okay, and so you can see it's very easy and very quick to change the date. The second interesting point, or the second section of the movement, is the function when the movement changes the date during midnight. So this picture, this is not the 6101 movement. It's a picture of our DOW 411. It's a hand winding movement, which is built in the classical traditional way. But you can see the normal use system here. The most watches with a date indication use this system. So it's the most famous principle of changing the date during midnight. If we remove here this cover, we can look into the wheel. And what you can see here, there's a very big spring, a rounded spring. And this whole wheel, also with this spring, rotates one time in 24 hours. And during midnight, here, this little finger gets in contact with a tooth of the date disk, and then the spring is tensioned. And after a special torque, the spring releases and the date will change to the next date. So because of this is the most famous principle, that's a very good system. But it's a very big system. You need lots of space to use the system. And if you want to build flat or thin movement, you don't have space. Nothing space. And so we had to invent an completely other system for the midnight date change. This picture shown this completely different system. Here in the middle, we have our program disk. In the technical view, it's a cam. And on the other part, or the other side here, we have here this finger, I can say. And if we go to the next slide, it's better to see here. Under this cam and under this finger, there are two wheels. The wheel in the top rotates 4 times per 24 hours. The wheel in the bottom rotates 5 times in 24 hours. But of course, the date will not change 4 or 5 times a day. That makes no sense, of course. And now there's a trick. The cam is connected to the wheel in the bottom, and the finger is connected to the wheel in the top. And so the cam rotates faster than the finger, and so the cam can control the finger. The cam can pull the finger out to change the date and pull it after that again back to the middle. It's very difficult to explain this function, so let's show a video. Here you can see the system in action. In the middle here is this cam, and you can see it rotates faster than this finger. Also you can see both wheels. And now the wheel lifts off the finger gets in contact with the date disk and changes the date. And after that, the finger gets again back to the middle of the wheel. Let's see it again. You can see the first time the finger passes the tooth, nothing happens. Also, the second time, the finger not get in contact with the tooth. The third time, 2. And now the finger is lifted off again, meshed with a tooth of the date disk and changes the date. Because the whole system rotates much more faster. It rotates 4 or 5 times a day. It took, or the speed for the change of the date during midnight is much more faster than the classical system, where the date wheel rotates only 1 time per 24 hours. So that means our movement needs nearly 30 minutes to change the date. With this high speed, also the downtime is reduced. The downtime, we call it, it's the time during you should not correct the date. We have a downtime of 90 minutes. There are 45 minutes before and after midnight. And during this time, it's not possible to change the date. You can try it, but it will nothing happen. The reason is we have a special protection system. Again, you can see it here, these 5 arm star. And here in the bottom, we have a wheel, and both parts are connected with the spring. So the technical speech, we have a clutch. Both sections were pressed together and rotate together. And if the torque gets too high, the clutch releases and both sections can rotate by the arm. And so this works. In this movie, it's during midnight. Normally, the movement would change the date because the finger is meshing with the date disk. And if you pull out the crown and try to correct the date, you can see it here. The wheel in the bottom rotates, but the 5 arm star and the top doesn't rotate, or just a little bit. And so it's not possible. You can try to change the date during midnight, but it's not possible. And the main idea was that most or lots of different brands for watches have different times for their downtime. Some brands say you should not correct the date during 10 o'clock in the evening to 2 o'clock in the morning, or 9 o'clock in the evening to 3 o'clock in the morning. And it's too complicated. Especially for people who own more than one watch. You don't have these numbers in your mind. And for us, it was very important to invent a system where you don't have to think about it. You can try to change the date. During midnight, it is possible, but you damage nothing. You harm nothing inside of the movement, and you avoid maybe very costly repair of the movement. Okay. And this, the beauty, the DOW 611 again. Before I ask you to have your questions, please let me brief you, summarize the main ideas after this presentation. So first of all, I have tried to give you an overview about our latest developments. The DOW Deutsche Uhrenwerke 3001 and 6101. The first one having no date, the second one has. The 3001 boosts with a thinness, shouldn't say height, of 3.2 millimeters, and the date featuring 6101 with 3.6 millimeters. Both calibers are really outstanding and makes Nomos watches due to their revolutionary and high-end craftsmanship movements. Thank you very much for your attention, and now back to Nicholas. Thank you.
Well, thank you, Theo. That was a fascinating lecture. I really enjoyed the technical perspective that you brought to it. I learned a lot myself, and I'm looking at the questions that are coming in, and it seems like there's a lot of interest from our audience as well. So we'll now move on to the Q&A portion of the lecture. If you have any questions for Theo or for Martina, please use Zoom's Q&A feature. You can type in your question at the bottom there, and we'll ask them. And I would like to start out the Q&A session with a question myself, if that's okay. Question for Theo. Where did you learn movement construction? Did you learn it in watchmaking school, or did you go to a school specifically for mechanical engineering? What advice would you give to someone that wants to learn similar skills?
I think a good way is to make a classical training of a watchmaker. So I can speak just for Germany. In Germany, we have a traineeship of 3 years, and then you are a watchmaker. So you have all the technical knowledge. And also you are able to move it by yourself. You have the handling knowledge, of course. But you don't learn the development of a movement. For me, I studied precision engineering. This is not especially for watchmaking. It's more for optics and for laser techniques. But you learn to design small, very, very small parts. And so it's very common to the watch industry. And yeah, first learning watchmaking is every time good, and design engineering, it's the second.
So Theodor, the precision engineering is on the mechanical side, right?
It's yes, it's also mechanical. Precision engineering is a mix of optics, of electronics, and mechanics.
I see.
For me, I don't need optics and electrics. Great, but I need the mechanical part, of course, and it helps very, very much during the design process for the movements.
All right, thank you for that. And I have a follow-up question, a similar question from Roger Gudjian. Roger asks, do you design in SolidWorks? And I can add on to that, do you design in SolidWorks or Autodesk Fusion or Autodesk Inventor? What's your favorite software to use?
The software to engineer the watches is the question. Nomos uses Solid Edge. It's a software from Siemens company, but you don't need a special tool or this tool to do watchmaking. Other brands use CATIA, SolidWorks, Inventor, Pro Engineer, for example. So it doesn't matter if the software is able to handle with three-dimensional parts, then it's okay.
Okay, all right. Let's see, we've got a couple questions from my friend Tim Lake. Let's look at one of these questions. So Tim asks, does the 3001 movement pass the ISO shockproof standard?
Short answer, yes. We did researchers before the movement, before a new movement comes to the market. We make lots of tests, and these shock tests is also in test. We make it by ourselves in-house, and also we use the Swiss Laboratoire du Poids. This is a special company which tests movements, not just for shock protection, also magnetic or any other things. And so, yes, we tested and it.
Okay.
There is an Inca block shock protection in the 3001, right?
It's an Inca block protection.
Okay. Let's see here. Moving on to a question from Daniel Silverman. Daniel asks, if I want to transition into watches as a career, what would your advice be?
Which side? Your side or my side?
I guess that's the first thing that you need to consider. Do you want to work as a watchmaker at the bench, or do you want to work in the business side of the watchmaking industry? So maybe Martina and Theo, maybe both of you can answer from your own perspectives.
Yeah, please, Martina.
So from my side, I would just say it's the love to beautiful objects, the nicer things in life, and also the estimation of quality in any real luxury has to do with quality. I think that to work in this business, you need to have a personal passion for products which last long, which have a technical where there is some craftsmanship involved, maybe also with a long tradition. So when you're already into that, this can also be old timers or whatever. I think that's a good start for a career in. If it is PR, when you're a writer or a communication expert, or if it is sales, doesn't matter. I think it's the love for watches is the best on my side. On Theo's side, it's a bit more complicated.
Yeah, I think if you are interested in working by hand and working with very, very tiny parts, watchmaking it's a good chance for a career. And yeah, then you can learn watchmaking, you can study watchmaking, and it's a good start of the career. Yeah.
I agree with both of your answers. From my perspective, it doesn't feel like a job. It doesn't feel like a career. It's just something that I love to do, and I wake up in the morning and I'm lucky to be able to work in this industry. Yeah, so I think we're all recommending if you're looking to make a transition into the watch industry to go for it. Let's see what else we have here. We've got a great question from Brendan Cunningham. Brendan asks, has Nomos ever considered using a micro rotor in order to achieve an even thinner movement?
Theo, did we?
It's a difficult question. Not yet.
Not yet. Okay.
Micro rotor is a very good system, I think so, but it would generate a costly movement and a costly watch, and I think so we would leave the normal Nomos price range, and so maybe in the future, maybe for our gold modelers, but I don't think so in the normal
Yeah, I think so. I think so too. When the briefing for a new technical development for Theo and his colleagues always includes the cost side of things. So where we are in the steel range between $1,500 and $6,000. So, and the micro rotor with all the assembly and development would definitely go beyond that. I think I'm quite sure.
Yeah.
Well, maybe we can look at this follow-up question from Brian Standig. It's kind of asking something similar. So Martina, I see that you were typing the answer, so maybe we can just talk about it live. Brian Standig asks, where he first says, "I'm really impressed with how nicely the Nomos movements are finished. Are they all finished by hand? If they are, how does Nomos maintain such a lower cost for their products than other hand-finished movements?"
So it's always a mix of high tech and machines and handcraft. Of course, in watchmaking, there's lots of handcraft involved, and when it comes to polishing, it's many of the things are done by hand. But hand, yeah, I think the level of finishing is really unique in our price range, but we save the money elsewhere, not in the watchmaking. It is in marketing. It is we are a really lean organization. When you look at the fact that we have over 500 point of sales worldwide, and we are 200 something people worldwide. We are a really lean organization. Try to organize things efficiently. We try to enable our retail partners to work without us. We don't rearrange their window every second week. So we don't have a huge sales force running around or driving around with big cars. So we spend definitely much less for marketing than comparable companies. So in the 90s, our saying was the price is the sum of the price is the sum of the parts and a little bit more. But it is part of our DNA to keep these products accessible and to sell them at a fair price. It is still, of course, we have some golden models, but there's also with 5-digit prices, but there's also much more handcraft there, and it's also the precious metal that makes the price. So yeah, I think it's not the watchmaking where we save the money. Definitely not.
Okay. All right. Thank you for that answer. Let's go next to a question from Hugh Wen. Hugh asks, how long did the development of the 3001 and 6101 take, and how many iterations and concepts were generated during the development period?
I can say Nomos is not a very big company. Our R&D team, we are 7 persons, and the whole time to engineer a new movement is between 3, 4, and 5 years. Normally, you can say 1 year to create the idea, to create all the design of the movement. 1 to 2 years, the whole prototyping. You produce the first parts, you test if your ideas work or doesn't, and then you have correct them. And in the last years, 1 or 2 years, you make studies about of the cases, of the dials, which is the shape, which is the character of the watch, and also you test a lot. And yeah, cycles in the development, there could be some rounds. If something doesn't work, you have to try it. You have to try it, try and try, and it doesn't work. You have to begin again. That's development. That's completely normal.
3 to 5 years with many rounds, I would say.
Yeah, you can say.
Okay. All right. Thank you. Let's go to a question from Angus Davies. This is actually a question for me that I'll very briefly answer. How do I obtain a copy of the recording? So the recording will be posted on our website shortly after the lecture, later today or maybe tomorrow. The recording is made exclusive to HSNY members for 2 months. After that 2-month period, it's available to the public on YouTube. Okay, and then this is an interesting question from Jefta Vitsohano. Sorry if I mispronounce your name, but Jefta asks, I've heard that Nomos supplies parts to independent watchmakers to service their watches. Is this true?
I'll take that over, Theo. That's the after sales part. Yes, we do. When we know the people, when we know the level of service that we can expect there. Most of our partners anyway have Rolex, Omega, and other certifications in, and then we don't see a problem here. Yes, we supply spare parts, but there is a checking process before that. And
that's great to hear, because I'm sure everyone has heard about the stories where spare parts are very difficult for watchmakers to get. So it's great to hear that a brand is supplying spare parts to the watchmakers that are qualified.
It depends a little bit on the movement. 6101 is really with the date mechanism is really complicated. Some things work different than a regular watchmaker would think that they work. Right, Theo? That's at least what our head of service is. So our 6101 is a movement we really like to see at home in Glashütte, but we are supplying spare parts.
Yeah, but without the complicated certification process like some Swiss companies, but Nomos, it's more easy for the customers to buy spare parts.
Yeah, so our certification process is so far individual, but we are working on that.
Okay, good. Let's move to a question from Cash Kunz. Cash asks, is Germany doing a good job of promoting and supporting the next generation of watchmakers?
You know this better than I do.
I think.
Are there any type of scholarships or incentives or promotions to try to encourage young people to consider watchmaking as a career in Germany?
Especially in Glashütte, there's a big school. There are both 2 big schools. You can learn the watchmaking here in a classical traineeship of 3 years. It's a federal learning.
Exactly.
And also the companies here also produce or make trainees for future watchmakers, I could say.
So I think Glashütte is doing a very good job there. We have the big state-funded school for watchmakers, and Nomos is supporting this school with experts and also with watches. since many years, tangente is what's the word in English? Apprentice? Is that right?
Apprentice, yeah.
The apprentice make their last test with a tangente and the tangente movement, and it's their watch in the end. They can keep this watch. So this is our incentive to learn watchmaking in Glashütte. If you make it in the end, you'll have a tangente.
Very nice. So we have a lot of questions coming in. We have over 50 questions. We're not going to have time to answer all of them, but we'll do our best. So my question for you both: Are you okay with continuing to answer questions? Do you want to keep going for a bit more, or should we end the lecture sooner? What's your preference?
Fine with me. I was ready to be there until 5:30. So
okay.
It's okay. More questions,
all right.
please.
All right, sounds good. We've got a lot of them. So here's a question from John Kirkjian. John asks, are there any plans for a skeletonized movement?
A skeletonized movement? No, I don't know any plans for this.
No, you see our faces? No, not really. Nomos is into useful complications. I mean, when you look at our development, we develop the stuff we really need. Date, stop second, stuff like that. GMT was the most fancy one. So I would say we're still not in the phase to for design experiments or whatever. No skeletonized movement before. Many other things before that, right, Theo?
I think so, yes.
Okay, all right. So we've got a question here from Bill Sanders. This question may actually be a good topic for a future lecture. Bill asks, how exactly does the swing system work? What is unique about it compared with a typical Swiss system? So you could answer it, or if you want to say, maybe wait until next year and we'll have a lecture on the topic, that's up to you.
Yeah, I think we can make both. We can make the lecture because it's a very wide and very difficult topic, but the main differences between the Swiss escapement and the Nomos escapement, the Nomos swing system is a completely designed from us. We make the whole calculations. We created special computer programs and computer software to calculate such a system. And when we had the knowledge of the system in details, we was able to produce such parts by our own. The differences are in the details. There are different forces, there are different torques, the shapes are completely different to the Swiss escapement, and they look nearly the same, but also the function is the but it's a completely in-house development of the system.
The thing is, there is no book where you can look this up, how to do that. It is an escapement is trial and error. There is no there are no tables or whatever to you have. One escapement is imitating the other, and we at Nomos, we wanted to do this scientifically. We wanted to be able to have all the mathematics. So that's why we bought high-speed cameras and looked what this funny hairspring is doing when you slow it down a few hundred times, and there were really very many unexpected insights there, right, Theo? These escapements many times didn't do what we thought they would do when you film them with a high-speed camera and then look at the single images. So the thing is, we wanted to control this process and not just like the watchmakers did in the ancient times with trial and error, put it together somehow. We wanted to be able to calculate and repeat this process, and that's what we are doing at Nomos. It sounds a little bit industrial, but it's very important for us to have this to produce such a big number of movements. It needs to be like with the Michelin star chef. It needs to be the same quality every single dish, every single movement. Yeah. And that's why we researched 7 years with the technical university. What is it about? How does such an escapement work? And there are tiny little differences, but the technically it is basically the same, right? There is no big invention there. It is just that we are in control of the process. And independent from Swiss deliveries. That's also a really important thing. Yeah. And also controlling the quality, of course. When you do it yourself, you control the quality.
It's a very big topic. Lots to learn and lots to think about when we're discussing escapement design and manufacturing.
Yes. It's a very big topic, and it would be a nice point for maybe next.
Yeah. It's actually one of the best moments in a manufacture tour is the look into the high-speed camera on the escapement. Yeah.
Yeah. Well, maybe the next lecture that we do, maybe it could be live here in New York, and you could come over and visit us. That would be a fascinating topic. And
you bring the camera.
Yeah. Let's see. We have a question here from Nick D. Nick asks, are any of your movements chronometer certified? And if not, are there any plans to do so in the future?
So, Martina?
You first, you are responsible for the accuracy, so that's your part.
What we have to say, the chronometer testing costs lots of money. So if we would make the certification of every single watch, the watches gets more expensive, of course.
$500 at least, yeah.
Yes, it's very expensive. But we have, for example, special editions where we make the chronometer certification. So we don't use the COSC, the Swiss certification, because we are a German brand. We can't use this. But we have in Germany, here in Glashütte, the German certification institute. And yes, we make movements with the certification, but I don't think that we really make it necessary.
No, from the sales perspective, I would add that all our movements are capable of chronometer levels, and we are regulating after this norm, but only a few limited editions have been certified, and the certification is different from the COSC certification in Switzerland, because up the hill at the WMP chronometry, they are testing every single watch completely finalized with case, with strap, with everything. And if it doesn't pass the test, you have to disassemble it and fix it and reassemble it and give it again to the test. In Switzerland, they are testing big charges of movements only. They are not assembled to the full watch. So that's what makes this testing more cost efficient than the German one. Yeah.
And also,
sorry, go ahead.
These tests are more difficult to pass, because if you just test the movements, when you assemble the movement into the watch case, something can happen, something can disadjust.
Yeah.
And so it's a way to chronometer certification. But if you test the complete finished watch, it's more difficult to pass this certification?
I agree with you completely. And the Horological Society of New York just recently launched its own chronometer certification program, and we're testing watches here in New York. Yes, and we do exactly the same thing. We test only watches that are fully complete cased up, so not just the movement. Yeah, so if you ever want to have some of your watches certified here in New York, we'd be happy to do it, and it's not expensive. It's very reasonable.
That sounds great.
But yeah, maybe that's a discussion for another time. But let's see here. We have we've got a very interesting question from Cash Coons. Again, Cash asks a question. How would the automatic winding efficiency compare with other Paul winding systems, such as those used by Seiko and IWC? Is Paul winding inherently more efficient? And are there any concerns about wear to the teeth and the pawls over time?
Oh, that's a very long question. We also tested Seiko movements, of course. These Seiko uses a completely other system with this so-called magic lever systems. So these are also efficient automatic winding mechanism, but there's an issue of abrasion. They need other service times, and for the 3001 or 6101 movements, we have higher service times, and the abrasion of the watch winding mechanism is not so high. So I hope this was this question.
I think so.
Yes.
I didn't really get that. This would need more service, another interval of service, or?
It needs another interval of service, yes.
Okay.
I have to read the question again, but I don't find it here.
I can read it out to you again here. So the question is, how does the automatic winding efficiency compare with other Paul winding systems, such as those used by Seiko and IWC? Is Paul winding inherently more efficient? And are there concerns about wear to teeth and pawls over time?
Yeah. IWC and Seiko both use this magic lever system, and there's a reason why IWC uses jewels or rubies for the automatic winding, and to avoid abrasion. And in the most Seiko movements, there are no jewels. This magic lever is connected directly to these wheels, and there gets abrasion produced.
So it's more. There's more friction then.
Yeah, you can say there's more friction inside of the system.
Okay. I see.
Okay. All right. Thank you for that answer. Let's go to a question from Daryl Liu. Daryl asks, how is the date change finger attached to the gear? How are the two stacked gears mechanically connected?
On this finger, there's a little pin, and in the wheel there's a hole, and the finger gets stuck to this. The pin gets stuck to this hole. It's very easy. It's not a screw or something else.
So it's like a press fit, right?
No. There's clearance. It's just stacked into the wheel, and over it,
okay.
there's a plate that the finger can fall off.
Fall off. Okay.
Okay. All right. Let's see, I'm scrolling through so many questions, and that's a good thing. It means people are interested in what you're talking about. Let's see, we've got a question here from Xiao Hong Chong, Xiao asks, to work in Glashütte, do I need to know German?
No.
No, okay.
In the
I was
watchmaking?
going to think that I was thinking the answer is yes, but you're saying no.
It's good to learn German because you can talk to the people, of course. But Glashütte is a very international city, especially the other brands. The customers come from around the world. Also, the employees are coming from around the world. And so you don't need to learn German, but I would advise, if you live here, then of course it's better to speak German.
We had watchmakers from Finland, from Korea, from I don't know where. Yeah.
Okay, well that's great to hear, and that's a good segue into this next question from Roger Gujian. Roger asks, I'm a mechanical engineer in California. How does someone in my time zone get into this?
I doesn't understand this question.
So I think Roger is asking, if he lives in California right now and he wants to get into watchmaking, could he do that in California, or would you recommend that he moves to Germany or Switzerland? How would someone in California get started in watchmaking, from your opinion?
I'm not so sure. I mean, actually, I would get in contact with one of the high-end retailers there, like where they have a good service department with every retailer with a Rolex certified service department. They have good connections, I think, to watchmaking schools, and I would step into a store with where they offer great watchmaking service and interview them. I'm not informed if there is a watchmaking school on this side of the West Coast, but
there is. There's one in Seattle, Washington.
In Seattle, okay. So, but always good to speak with experts about that. And my first step would be into a place where you find many of these timepieces you like so much. Yeah.
Absolutely. And Roger, if you're still tuned in listening, please feel free to get in touch with the Horological Society. We can give you some advice on that as well. Let's go to a question from Walter Pangertish. Walter is a fellow of the Horological Society, and I'm very happy that he's tuned in today, and he's got a great question. Walter asks, is there anything unique about the balance wheel in the 3001? It looks very thin with a smooth rim.
From the question, unique to what, in comparison to what?
Maybe in comparison to like a balance wheel on a standard ETA movement, it looked thinner. Are you making them thinner to help with the overall thickness of the movement?
Yes, you can say they're a little bit thinner from the material size. Also, we have differences during the teeth of the escape wheel, especially in this area where they mesh with the pellets of the lever. There's the material very, very thin. Normally, other brands often use an angle to make the lubrication better between the escape wheel and the pellets. And we have a little step, I would say. And yeah, for us, it was better than to use an angle. I hope this will answer this question.
Absolutely.
Okay.
All right. Well, thank you for that. So let's. I think we could wrap up the lecture today in the Q&A session with a final question, and this is a question that I see many people asking in the Q&A feature, and it's they're all basically asking the same thing, but just a little bit differently. They're asking, what is next for the future of Nomos? Are the watches going to be even thinner? Is there going to be a new complications? Is there going to be a moon phase, a chronograph? Can you give any hints as to what to expect for the future of Nomos? I know you probably don't want to tell us exactly what your product
you won't talk
for the next
about
few years.
Your R&D secrets here, please.
Yes, please tell us all the secrets.
Normally, we would never talk of these issues, and today it's the same.
So just look into what we developed over the past years. So to be able to offer our prices, our watches at the prices we offer them, we have to have an efficient platform strategy. You see that 6101 is not only in Tangente, it is also in a club sport with date. So it is all this slim date movement is also used to have a sporty 3,000 feet waterproof watch with date, and we can afford these thick sapphires on both sides and all that stuff because of the slim movement. So we have to use our developments not only for one watch model but for many. And so the next big technical thing, of course, we will not tell that, but it will be a useful complication for sure. So if it's a chronograph, if it's really that, or if it I would also think a moon phase is a really useful complication, but there will not be an eternal calendar, and it will be something that fits in our range. But okay. So in 6101 was 2018, so maybe you don't have to wait much longer. Let's see.
Okay. Nice. All right. Well, thank you for giving those hints. I'm looking forward to seeing what's next. And I also want to thank you both for just this incredible lecture and this very lengthy Q&A session. This has been a lot of fun, and I thank you both for giving this lecture today.
Thank you very much, Nick, for this great opportunity. It was fun, and we're looking forward to the next time in real life. Yeah.
Absolutely.
Okay.
All right. So thank you everyone for tuning in. The next lecture that we're going to have is going to be in May, because we have the April Gala. So I'm looking forward to seeing everyone at the Gala. Looking forward to seeing everyone back here in May. Thank you all for tuning in, and thank you again to Theo and Martina for this incredible lecture. Have a great day, everyone.
Thank you.
Bye.
Goodbye from Glashütte. Bye.